Okay, bachcho, let's solve question number 4. Question number 4 is figure 7.1 shows a compass needle near a bar magnet. Magnetic poles are shown on the compass needle and on the magnet. A finger stops the compass needle from turning. So this finger is stopping the compass needle from turning. Now, what is the question? The magnet causes a force on the south pole of the compass needle on figure 7.1. Draw an arrow from the south pole of the compass needle to show the direction of this force. Now, we have to understand that on the compass needle, the north and south both will apply a force. This is not the answer, but initially the understanding. The south will repel the south. The south will repel the south. And the north will attract the south. The north will attract the south. Now, if you have studied vectors, then you should know that force is a vector. And when two forces act together, we get their resultant. For example, if this is force from south, if this is force from south, and this is force from north, then we will get the resultant force that will be from the tail of the first force to the head of the last force. So this is the resultant force, and this is the force that we are supposed to draw. So this resultant force will appear to be horizontal and obviously towards right because south pole is attracted towards the north pole. So the answer will be you need to draw an arrow, a horizontal arrow. Why horizontal arrow? It has been explained here. South will repel south pole, north will attract north pole, and we'll get a force like this. Now we should move on. Explain why the compass needle turns when the finger is removed. So when we will remove our finger, the compass needle will have two forces. Force on south is towards right. Force on north is towards left. So basically we have two forces which are equal. They are opposite and they are not in line, obviously. So if you get a situation where you have two forces at the ends of an object and the forces are not in line, then they cause rotation. So if you have two forces at two ends of the object which are opposite in direction and not in line, then they will cause rotation or turning effect. So we should say that forces at opposite poles, forces at opposite poles are opposite and not are opposite and not in line, so they will cause a turning effect or net moment. The net moment is also called the turning effect. Now B part of the question. B part of the question is a small compass is used to plot the magnetic field lines of the magnet. Describe how the compass is used to plot magnetic field lines on a piece of paper. Basically, as you can see, the compass has north and south marked. So this north will point towards the south and this south will point towards the north whenever this compass is placed. So we'll say place compass at a position. So you can place it at any position initially. So place a compass at a position around the magnet and mark an arrowhead to represent the north pole, to represent the direction of north pole, to represent the direction of the north pole. Then then move the south pole to the arrow. In this way, the compass will move. In this way, the compass will be displaced, or it will move. Will move to a new position, new position, mark an arrow for the direction of north pole. Continue this until you have arrowheads from one pole to the other. Join these arrowheads to get a magnetic field line. Repeat the procedure to get many magnetic field lines. Repeat to get many magnetic field lines. So in this way, you can use a magnetic compass to plot a magnetic field around a magnet.